So this is the part of the mass spectrometer. Mass spectrometer is the instrument that used to test the isotopes, abundance of isotope to determine the relative atomic mass and even the molecular structure, structural formula of the isomers. So these are the things. Now, when you look at it, you have five steps. One is vaporization. Okay, they become gases particle, and then the production of positive ion by bombardment of high energy electron from the hot filament, and the acceleration of the positive ions in the electric field. You have to say acceleration of positive ion in the electric field, and then separation or deflection. For me, I like deflection more than separation. Deflection of the ions in the magnetic field, where the deflection is inversely proportional to the mass, and then directly proportional to the charge to mass. Okay, no? So higher charge you deflect more, or faster to be deflected, or lighter you deflect more. Okay, so you explain the deflection, angle of deflection in terms of mass and charge only. Okay, and then detection of the ion is the final stage, and then you produce a mass mass spectrum. Okay, so these are things that you use to do analysis. So vaporization, ionization, acceleration in electric field, deflection in magnetic field. Okay, no? Deflection is where we can separate the ions. Now, those who are not charged, it will be removed from the vacuum over here. Okay, and finally, it will be detected. Okay, and then it will be producing the mass spectrum or mass spectra to be analyzed. Okay, so yeah, very fast go through it together. So this is things. If you want to look it clearly, you just pause it later. Okay, vacuum pump is still used to remove the air inside the mass spectrometer and also remove the uncharged particles. So when you are asked to analyze the mass spectrum, you must tell me that every species in the mass spectrum with the peaks, PEAK, the peaks over there, belong to charge 1, because the SS is mass to charge divided by charge. So everything inside must be positive charge. And then if I ask you, what is the molecular formula? Then you have to deduce from the positive charge. For example, if you get a CH4 positive, then you will say the molecular formula is CH4. That's it. So inside the spectrum, when inside the mass spectra, it is positive charge. But before you put into it, it is CH3. It is a molecule. You get what I mean here? So you have to read the question carefully. Okay, so if they are asked to analyze the fragment inside according to the mass spectra, the peaks there given to you, showed to you, okay, where is the piece? This is a piece. Then every one inside here are positively charged. Okay, no? Now, if I ask you to deduce, okay, what is that? Then the whole thing will be remain uncharged. It means that the sample that before you put into it, okay, no? Inside the system, it must be positively charged, or it will be removed, because this is mass to charge. So based on this diagram, when I told you last time, based on the basic diagram of the mass spectrometer, you can analyze 3 criteria already, right? So when you look at this mass spectra, 54, 56, 57, 58, they are very near to one another. Okay, they will be different by 1 neutron only. Okay, because 57, 58, if you look at the proton, if you change a proton, they can change an element. So in this case, most probably, it will be change of the, because it says this is an ion Fe. Means that if you have the same proton number, but why you have different mass? Because you have different number of neutron. So ion, if it is ion, the proton number is stacked. Okay, is it fixed? The proton number is fixed, and then everything here, this is a total mass of the proton and the neutron. You minus the proton, you get the number of neutron already, because one neutron is 1. Okay, for the mass of it. So this is things when you will say this is thing 1, 2, 3, 4 peaks here. The first deduction is ion has 4 isotopes. First deduction. Second deduction is what are the isotope of the ions? Ion 54, ion 56, ion 57, and ion 58. And third deduction is which isotope exists in most abundance? All right, of course, it's ion 56. Again, no? 56 here. So ion 56 has the highest abundance. And then lastly, from all the document here, information over here, how do you determine the relative atomic mass? Now, each and every one here are relative isotopic mass. Isotope doesn't have any decimal place, because 1 proton is 1, 1 neutron is 1, right? Okay, but once you do an average, you average 25 times 40, 54, then this one times this one, all a round figure. But once you get an average, at least you give me 1 decimal place, 1 to 2 decimal place, all right? Because you need to get an average figure, okay? So normally we use 1, like chlorine is 35.5, right? Okay, so the figure below shows the mass spectrum for boron. Again, first you look at it, you have 2 peaks. Now, what are the 2 peaks? Boron 10, boron 11. Oh, 2 isotopes, boron 10, boron 11. It will be like this. Okay, no? And then you will say the abundance of it. Okay, boron 11 is higher. You know? And then when you get the average mass, you will get the relative atomic mass. Okay, so I want you to do a revision on your with you on the equation that we normally use. Okay, what is the color of this pen? Okay, it's I choose a yellow color. So I want you to like see, for example, this is the x. For example, if you want to ask to find x and y, so why you do that? How do you do that? You will say x x times 10, okay or no? Okay, plus okay y times 11. Actually, you have it there. If you use percentage, percentage you need to divide it by 100. 100. Okay, then equals to the relative atomic mass of the boron. Okay, relative atomic mass of the boron, and then you have to do the second deduction, s plus y. If your percentage, percentage is 100%, right? So s plus y is 100. Okay, or no? So I don't like 100. I like to put this in 1.00. If I put 1.00, like for example, if I calculated s equals to 0.83. For example, okay, 0.23, then you will know that the percentage of S will be the abundance of the percentage of S will be 23%. How to write 23%? So this one you understand, huh? So how do you do it? You must remember, if you use percentage like S plus Y equals to 100, then remember over here, you must put 100 behind it, below it. You must be divided by 100, then that is the average. Okay, you have to look at the average. But if for me, I don't like to have so many figures, so I will change the 100 to 1 only, 1.00. So then I need to do extra step. So if I want to have figure 1, no percentage, then my extra stage is convert the answer that I calculated into percentage, like 0.23, I will have to convert to 23% at the end of the final answer. Understand? Oh, can you hear me?
Okay.
Okay. Because I changed my speaker, the previous speaker has been spoiled, right? And then it have a lot of noise behind it. So I don't know how is this quality. Can you hear now clearly? Because I feel like I can't hear very clearly in this speaker.
Okay.
You still okay, huh? Okay, never mind.
Yes.
The mic is okay now. Okay, we continue to the next thing. Okay, I need to clear my anatop. Where is anatop? Okay, clear all the. Okay, let's continue. Now, mass spectra of the molecule. Mass spectra of the molecule. Okay, this one, you have to be careful. So means that whether this is a simple covalent molecule or is it a organic molecule. So simple covalent molecule, you will be properly just refer to isotopes like HCl, HBr, NH3. They are still belong to simple covalent molecule. Then if it is an organic, how do you know? Organic is still also a simple covalent molecule, but organic is just like you need a fragment like isomer like aldehyde and ketone, primary alcohol and secondary alcohol and tertiary alcohol. This is isomer. So you have to know that whether you are answering the isotopes or you are answering the fragment of molecules. So if you know that, if you see something like this, okay, like this, okay, yeah, it is very different by very little too, but because it is different by one hydrogen. Hydrogen is one, it doesn't have any neutron, right? Normally, but deuterium and tritium have neutron. Okay, so normal hydrogen doesn't have any neutron, so just one. So if you look at things like this, okay, it says that mass spectrum of methane. Do you see it? Just now is mass spectrum of boron. Boron is one atom. Oh, mass spectrum of hydrogen chloride. mass spectrum of nitrogen, or mass spectrum of carbon dioxide. Now, they will all belong to the previous question here, belong to this. You have to look at the abundance, you'll find the average relative molecular mass, or you'll find the relative atomic mass, all right? But if you look at things like this, you will see when the question gives you something like methane, ANE, then you know that it is alkane, or alkene, or alcohol isotope, or we say ketone aldehyde. Something like you think, when you look at the name, is an organic name, then you will have to know that I need to do the other way around. I'm not going to answer like previous. Again, I'm going to find the last highest peak, 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 last highest peak. So last highest peak means that, for example, over here, this is very little, this is very little, so I will ignore this too, right? So it will say that this is m plus 1. Okay, let me write. Okay, in the top. Okay. So this is the highest, so this part is the molecular ion. So m plus, okay, not m plus. It should not be m, it should be m plus. Okay, everything inside the spectrum you must put a positive charge. For example, okay, here this is correct. Okay, positive charge. Okay, positive charge, and positive charge, and this is positive charge. So this is m plus. But by having m plus, you can deduce your molecule. Okay, means that what is the fragment? For example, if I say what is the fragment at the mass to charge value equals to 16? Yeah, equals to 16. If I say what is the fragment mass to charge, you see the word charge, then I have to say my fragment will be CH4, okay, to the positive ion. Okay, my mouse not functioning well, but you know this is positive ion, right? So you have to write like this, CH4 positive. But if I don't say anything, I just say, what is the molecule? What is the molecule that the sample, the molecule of the sample, then molecule. So you have to write me the answer without any charge. CH4, that's it. I don't know why my writing today is like this. Okay, never mind. My mouse don't want to cooperate with me. Okay, we continue to the next thing. So in this thing, maybe you feel that this is more complicated. Actually, the way to solve this problem is easier because you just need to find the molecular fragment, okay, the molecular ions, find it out, okay, then this will be directly the relative molecular mass, directly relative molecular mass. You don't have to calculate it. And then from here, you start to deduce, 12 must be carbon, or one must be my hydrogen. Now, a little bit, we just ignore it because this seems to be impurities, okay, no? And then you need to know methane, and me is 1 carbon atom, ANE is alkane. So CnH2n plus 2, CH4. This is the things, because if you have 2 carbon atom, it must be exceeding 24. 12 plus 12 is 24, right? 2 carbon atom. So this must be methane. So all the fragment inside here, this is fragment, like a part of the molecule. This is the molecule, okay, part of the molecule. So we're told that this is fragment of molecule. All right. So this kind of question, I don't see it recently. So it means that if you understand, you just understand it yourself. So how to solve the problem? The problem is like, if you are given this kind of question, okay, if you know that this is an isotopes, okay, or not, then you will have to find the relative atomic mass by calculation. Or you find the abundance like previous equation that I show you. S is what? You have to build the two equation, and then you solve one of it, and then you answer it. How much is the abundance of it? And then if it is like this, a lot of fragment, and tell you that this is organic molecule, the first step is find the molecular mass, and this will be the m plus 1. M plus 1, okay, no? M plus 1. M plus 1 due to the presence of carbon 13. You just answer like this, okay? And then in front, you just write all the fragment, okay? Because you know the molecule already. So I will draw it again. Now, if you know the molecule already, is C, see my C look like 6. So you know this is my molecule, my H, okay, H. And over here is another H, okay, H. So if you know that this is my molecule already, so this is CH4 plus. Now 17 must be because my carbon is 13. Then I have a 17. So this is M plus 1 bracket fragment, positive, 1 positive, all right, M plus 1, due to the presence of carbon 13 isotope. So you have this as your keyword. Just be patient with that keyword. Okay, so your first thing you have to look, second thing must be due to the carbon 13. So you have M plus 1 fragment. And then 13, you start to analyze each and every one in front here. So 12 must be my carbon only. Okay, this part. So C plus. Okay, 13 or 13, 12 plus 1. So CH positive. 14 or plus CH4, CH2 positive. Now it's 15, it must be CH3 positive. It must come from the fragment of the molecule that you have. Then this is everything that you write here, you remember to put a positive charge. That's it. This is the things that you have to take note. All right. Okay. If you write it wrongly, you don't have the charge, means no 0 marks for the fragment that you have answer. Okay. So this is how you do it. Okay. If you have any more questions, you just PM me, personal me. Okay. I will give you some exercise. Okay. But STPM question not much. Okay. Just exercise. Okay. So molecular ion as a parent ion. Okay. This is the relative molecular mass, and then so this is some of the example when I look at it. This is very high over here. This is CH2OH, and this is the CH, and then it is not the last line, even though it exists a lot, but you see the last line is over this 3. When you have this 3, ignore the very small scale over here. So this must be M plus 1 peak. Okay, so you took one, this one have a high abundance around near to 20%. So it means that this must be my molecular ions. Molecular ion, okay? Molecular ion M plus. So it is an ethanol. So ethanol, then if you are 1 by 1 smaller, then lost 1 H, and then the rest you just do fragment of it. Okay, no? So choose this as molecular ion. Choose this as M plus 1 molecular ion due to the presence of what? Carbon 13. Okay, this is it. Okay, carbon 13. All right. So next thing, there are more examples here. You pause yourself to understand yourself. Okay, no? Okay, so we continue to the next example. Okay, this is one of the example. Now, this example that I want you to memorize, where chlorine 35 is 3 to 1 of chlorine 37, 3 to ratio 1. Memorize it. And then if you also memorize the relative abundance, that 3 times 3 is 9, and then 3 times 1 plus 1 times 3 is 6, and then 1 times 1 is 1, so it's 961. 961 for chlorine 35, chlorine 35, 37, and chlorine 37, 37. You understand it? Because you have studied, those who have studied semester 3, you know the probability, right? You know how to calculate now. Okay, so these are things. Okay, 961. Okay, no? So I think lower 6 student, you understand this thing, right? Because 3 to 1, the overall is 4, right? So the percentage of chlorine 35 is 3, so 3 divided by 4. If both of the atom are 35, so 3 divided by 4 times 3, you get the 9 divided by 16. This one you understand, right? Okay, no? So if you have 35 1, another is the positive charge at the 37. So this is 3 divided by 4 times 1 divided by 4, right? 3/4, 1/4. Okay, you get this thing. And then you have another probability of 37 to 35, where the positive charge is at the 35, right? So again, 1/4 times 3/4, you get 3/16, right? And then these two, they will lie on the same value, same, because their position different, but the total mass is the same, right? So you will still have the mass to charge value of 72. This is mass to charge value. Okay, mass, MASS to charge. E is charge. Okay, and then 37, 74, you have 32, 37. So since both of them are the same, so you don't have to switch anymore. Just 1/4 times 1/4, 1/16. So as a ratio is 961. 961. If you want to convert to percentage, how to convert? So you have to 9 plus 6 plus 1 become 15. 9 divided by 15 times 100, right? So I think you understand how to do conversion, okay? So if I ask you to write the intensity, you just write 961. If I ask you to write relative abundance or percentage, you need to convert 961 into percentage, and then you draft on the mass spectra here. Okay, now this is another question actually. Another question said hydrogen chloride. Okay, so hydrogen chloride, it belongs to the first part. Second part is molecular ion. Okay, no? This one, HCl, it belongs to the isotope. You look at the isotope. So hydrogen chloride as a molecule. So hydrogen chloride, if you calculate, is 35.5 plus H, 36.5, right? So, yeah, 36.5. Okay, so in this case, you have 37 and 38, 36, 35. So what are they? So you have to analyze yourself, okay, or no? So you look at the things. 35 must be my chlorine 35. So you just write chlorine, yeah, my pen 35, okay, no? Then you put a positive charge here. And then, you know, the second isotope of chlorine is not 36, it is 37. Yeah. Remember this thing? I want you to memorize the isotope of chlorine and bromine. Bromine is 79, bromine 81. Okay, no? So this one you have to remember. Okay, and then this must be my molecular ion, HCl, positive charge, and my chlorine must be my 35. Oh, you see my handwriting. Okay, so over here is H. Okay, over here is 37. Okay, and then chlorine plus. So the fragment inside the mass spectra, the whole thing over here, you must always put a positive charge due to the word here, mass to charge. If you forgot to put a positive charge, you divide by 0, you get infinity, you won't get this value 35, 36, 37, 38. Understand? Okay, always be careful in this question. This question is easy, but students always lost mark for the careless mistake. Okay, so if you have things like this, you will just have to calculate yourself, or whatever things that you need to do. Okay, yeah, very easy for teacher to say, right? Calculate yourself. Okay, yeah. Okay, we continue to next question. Okay, these are all the things that you need to analyze yourself. Okay, later you post it and you analyze it. Okay, okay, and then this is the fragment again. The fragment again. These are all the examples. Okay, now this is our previous picture. So until here, any questions? No. Or you get sleepy already? No response, huh? Okay, so I proceed. The relative atomic mass vs the abundance. So this is still very important because sometimes you need to know about this thing. Okay, and we just memorize that 75 and 25 enough. Don't do to one decimal place. Okay, the isotopes name is carbon 12, carbon 13, carbon 14. The symbol will be 12 out, down is proton number, 13 out, 6 down, 14 out, 6 down. Okay, this is symbol of formula. All right, and then number of proton is the same, number of neutron is different. Okay, the percentage of abundance will be like this, the trace. So empirical formula is what? Empirical formula is simplest whole number mole ratio. Okay, that of each element present in a compound. Okay, simplest whole number mole ratio. Okay, that presence in each element. The molecular is exact, okay, or total number, actual number of the atoms of each element in a molecule. Okay, no? So this is the empirical and molecular formula definition. And secondly, that I want you to remember is another thing is like this. So if you know that, for example, my molecular formula, empirical formula that I calculate is CH2. For example, just for example, CH2. And then I will have to say my molecular formula must be bracket CH2 bracket. Okay, where's my bracket? Bracket N. So if empirical formula is CH2, okay, now, then my molecular formula must be bracket CH2N. Okay, so CH2N. And then when I want you to write the relative molecular mass, okay, if you are given to give some value, for example, my value is 30, don't want 30, 20, 24, 28, for example. Okay, 28. For example, I give you as a 28. So how do you do? So you will have to say 1 times 12, or 12.0 is my carbon, okay, plus 2 times 1.0, 1.0 is my hydrogen. You must have 1.0 there. And then you bracket overall, okay, and the n is no longer down here, small subscript here is now exactly the same. So you find 28, and then after you calculate, you'll find your n equals to 2. So after you find your n equals to 2, you have to answer back again. Oh, my molecular formula must be C2H4. Understand? Understand? So I want you to write clearly, okay? When do you do the empirical formula? Empirical formula just directly get the mole ratio from the things that you calculate, okay? The things that calculate is a percentage by mass, the first criteria. You always don't know how to label it, right? So now you must learn how to label it percentage by mass. And then the second thing is find the mole. And the third thing is simplest mole ratio. Okay, no? So you will get this calculation, mole ratio. Okay, and then you will have to write the molecular formula. You bracket, put a small n over here. The size is the same as 2 here. Okay, and then when you do the relative atomic mass, molecular mass, then you have to 1 times 12.0. 0.0, I emphasize it. You must get the exact figure from the periodic table, or else you lost mark on the accuracy. Okay, and then 1.0 from the periodic table, okay, for the hydrogen, and the whole thing bracket again, n now is bigger. Okay, then you calculate. You don't have to show me how to calculate, but just give me the final answer of n is 2. Then you write back to the molecular formula is 2 C2H4. Okay, now then you have to be careful, because if you ask about molecular formula, then you stop here. But if you ask about structural formula, then you have to draw more. Okay, now you have to draw more, draw all the bonding, get to the structure of the physical chemistry. If I want you to do the structure, don't give me 90% and 90 degree. Okay, you have to draw a tetrahedral shape. Very sorry to say that. Okay, tetrahedral shape. Okay, now a tetrahedral shape of the H. So you have to draw things like this. Okay, no? So learn to draw a Z value, because valence shell electron pair repulsion rules, it is included in the syllabus of semester 1. So when you start to draw molecular formula, write the molecular formula is easy, but draw the structural formula, you have to obey the valence shell electron pair repulsion rule. Okay, you no longer draw like across here, 90 degree, 90 degree, 90 degree, 90 degree, okay? So you have to draw tetrahedral shape, unless if it is a, I having alkene, right? That's not wrong. I shouldn't draw this. I need to draw alkene, especially alkene. Then I know that I have a double bond here. So I need to draw 120 degree here. Yeah, that's a, okay, 120 degree, especially if it is an alkene. So do you understand? Or everyone get sleepy already? Yes? Oh, because I didn't admit in-sync here, so none of you want to talk.
Yes, yes.
Yes, okay. All right. I'm running out of time again, so I will have just to clear everything, clear all my drawing, and done the anti-knot. Okay, let's look at the gaseous step. Okay, again, it will be very fast again. In 10 minutes, we will complete our gaseous steps. So gaseous step, I want you to memorize all the formula first. And tonight, I will give you some exercise on past equation. I lost it. I really prepared it, but I don't know where I saved it. Later, I have to search out. Okay, that's why today I was a little bit late. I'm still searching for my document. So these are the past equation. I have compiled everything that gaseous in one exercise, all the past question about gas. Okay, so you need to remember the Avogadro's law, Boyle's law, Charles' law, and Dalton's law of partial pressure. Now, Dalton's law is a little bit longer. You need to say Dalton's law of partial pressure. Okay, at the end of this chapter, at the end of this semester 1 chemistry, you are having another one is Raoult's law. Raoult's law is about the vapor pressure from the liquids. Okay, from the miscible liquid. So I remember this thing. It's also about the gas that has been vaporized. Okay, you apply to the Dalton's law of partial pressure. So I hope you can connect it. Okay, never mind. I'm going to do a fast revision with you. Okay, later. Okay, we complete this thing within these 2 weeks. Okay, before the school starts. So Avogadro's law, it is learned in your form 4, where the size of the space that occupied by the gas is not depends on the size. Okay, means that if I have a big molecule like carbon dioxide, or I have a small molecule like hydrogen gas, H2, the relative molecular mass for H2 is 2 only. Okay, 1 plus 1 is 2. And the relative molecular mass for the carbon dioxide is 44. 2 against 44. So one is small molecule, another is big molecule, but eventually 1 mole of each gases occupy the same volume. So as a conclusion, according to Avogadro's laws, that the gas has negligible volume, itself has negligible volume, gas molecule. So no matter how big or how small it is, because they are too small to be something. So we just ignore the size of the molecule itself. So we say, even though you have small molecule, large molecule, the space occupied by the gas only depends on the number of gas. number of mole of the gas. So 1 mole of small hydrogen gas occupies exactly the same volume as the 1 mole of the big molecule of carbon dioxide. Yes, understand? So this is what you have learned in your Form 4. No matter what is the gas, how big or how small is the gas, because they have negligible volume itself. So the space occupied by the gas is not determined by the size. It is determined by the number of mole of the gas, all right? Number of mole of the gas. So no matter big molecule, small molecule, they occupy exactly the same space. So we said, if I say 1 mole of gas occupied at RTP is 24.4 decimeter cube. So if I say molar volume, you need to remember to put a per mole behind it. Now, a lot of students forgot. They just said 24.4 decimeter cube is wrong. 24.4 decimeter cube is 1 mole of gas occupied 24.4 decimeter cube. In front, you write 1 mole. But if you say molar volume, you have to move the 1 mole to the opposite direction. It is 24.4 divided by 1. Divided by 1, so molar volume, the word molar here means each mole. So you have to write the 24.4 decimeter cube per mole. I remember this thing. So at RTP, the temperature is 25 degrees Celsius. Pressure 1 atmosphere. Okay, normal pressure. But for the standard temperature, the temperature here is 0 degrees Celsius. In other words, it's 273 Kelvin. Now remember this thing, because it's not so emphasized in Form 4, but it is very emphasized in Form 6, especially in physics. Okay, so these are physics law. Now in chemistry, I need you to learn to write in 3 significant figures. So from now on, you always remember RTP always 24.4, STP always 22.4. Don't stop at 24. Okay, not 24. Yes, because from this is advanced level. You have to be very specific with the significant figure. 3 significant figure, 3 significant figure. So ignoring the size of the gas, okay, the volume is directly proportional to the mole of the gas. Okay, the volume occupied by the gas is directly proportional to the number of mole of the gas. Okay, providing the temperature and the pressure constant. Okay, constant. Okay, so how about Boyle's laws? Boyle's laws, this is the formula, not the equation. If you are asked to define the equation, so you have to write volume of gas is directly proportional to the number of mole of the gas, providing the temperature and the pressure are, I feel that my mouth today is not good. Temperature and pressure are constant. Okay, you know, I want to write constant here. Okay, that's just bracket. Okay, so Boyle's law just say the volume of gas, the volume occupied by a gas is inversely proportional to the pressure. Inversely proportional to the pressure, providing the number of mole and temperature are constant. Okay, temperature and number of mole constant. Now after that, because you have to do something like V proportional to 1 over P, this is the definition. Don't write this formula in definition. This is derived formula for you to do the calculation. Okay, this is definition. Definition, we want you to write in directly proportional or inversely proportional, something like this. All right, but you will know that these are constant. Then when I move the V and when I move the V P to the other side, so P and V will be relative proportional to 1 constant over here, constant, and then you will derive it as P1 V1 equals to P2 V2. Okay, it's hard for me to write using mouse today. Okay, so this is this. So when you bring the P out here, okay, it's PV proportional to constant. So P1 V1 equals to P2 V2. Only then you get this formula. All right. But if it's objective, you just write that directly use this formula to calculate. Now, P1 V1, P2 V2, how do we use it? We usually use it in this occasion. This one, I just draw it out so that you remember this thing. And initially over here is gas A, and then the valve over here is locked, and then you have a B over here. Now after the valve over here open, the gas A diffused to this B, and gas B diffused to A. So what happened? So you use Boyle's law to calculate the P2 pressure for the A, and then you use Boyle's law to calculate the P2 pressure for the B, And then you use the formula of the Dalton's law of partial pressure, where the total pressure is the sum of the constituent partial pressure in the container. So it means that P2 of the gas A, PA, plus P2 of the BPB, add together is the total pressure, P total. Am I too fast? Understand? Oh no, too fast, not too fast. Oh, you are away, you are not here, you just open it. All right, so continue to the Charles law. Okay, Charles law. Charles law, the volume of gas is in directly proportional to temperature. You just say in Chinese that you have learned in primary school, 热胀冷缩这样子. So if the temperature is high, the volume is higher, or the temperature is low, the volume occupied by the gas is smaller. Okay, then again, you just bring forward. Okay, bring forward, you get the formula of this thing. This is derived formula. Don't write this formula for the definition. Definition must write this thing. Okay, define everything. Again, bring out the constant. Okay, you can write the formula over here, but you have to write in words also, right? Definition, because SDPN will always ask you to define first, then you calculate. Now, when you start asked to calculate, then this equation come out. All right, or if you don't know that whether you use Boyle's law or Charles law, then you directly use P1 V1 T1 equals to P2 V2 divided by T2. Directly use the general gas law. That was general gas law. Okay, and then Dalton's law of partial pressure, you must memorize the definition also, where the total pressure of the gas is the sum of the partial pressure of the constituent gases in the container, providing the volume is the same. Okay, the volume and the container is closed, and the volume occupied by the gases are the same. Temperature are the same, of course, like temperature and volume. Okay, and then you have the PA equals to SA by T2. SA is what? S1, SA is the number of mole of gas A, okay, divided by N total. Okay, now, so you need to learn how to define partial pressure A too. Partial pressure A. So partial pressure A is the pressure exerted by the gaseous A, it exists alone in the container, in the closed system, okay, container in the closed system, under constant temperature and volume. So this is the exists is it alone. Definition of partial pressure, definition of Dalton's law of partial pressure, and definition of the application of this thing.